Hello everyone, this is the first lesson recording for IM2, March 8, 2021. We started by going over the answers to quiz number 3. I hope you were there, or if you were not and if you'd like to go over them, please reach out to me and I'll be happy to meet with you, because the retake opportunity is going to be available for you if you scored 85% or lower. And it is going to be on Wednesday, this Wednesday at 12:10. Remember that this Wednesday follows the 8-day schedule. There is no cohort Wednesday. That instead you get Friday off. Okay, so I am going to be seeing you for IM2 on Wednesday at 9 o'clock and 10:50 respectively. So remember, retakes. Some of you said that the reason I haven't been taking retakes on quizzes is because I'm afraid that I was going to score lower. That's bogus, because even if you do score lower, we're going to be keeping the higher score. Alright, so the only way the score is going to change is by going up. So please take advantage of the opportunity to improve your learning and your grade. Okay, this will be an extension problem. See if you can figure this out. Okay, so we did a similar problem with the hot tub, remember? But this is another problem similar to it. Gabby is creating a decorative rock garden that will cover 12 square feet of her backyard, including its frame. She plans to build 6-inch wide wood frame around the rock garden to keep the rocks in place. If the frame rock garden is square, how much area will Gabby need to cover with decorative rocks? Draw a diagram, label what you want to find as X, and write an equation to represent the scenario, then solve the equation. So first thing I would like you to do is find the side length of the rock garden. You can label it X, that's what we're trying to find. And then from here, the final goal is to find the area of the rock garden. Here it says, how much area will Gabby need to cover with decorative rock? That's what it's asking. So when you have your answers to A and B, please tell me in private chat. And those of you doing it through the video, please pause the video and see if you can solve it yourself. Here we go. Okay, so if this is my rock garden, then we can call this length X, and the other length is also going to be X. We're also told that each of the frame is going to be covered in 4 sides by the frame, which is going to enclose the rocks, and they are each going to be 6 inches in width. So we can add 6 inches on either side of the X, so it's going to become, this total length is going to be 6 plus, or X plus 6 inches, and another 6 inches, which is same as 12 inches, which is same as 1 foot. So I can represent this total length as 1 plus X plus 1 foot. That means the area that is enclosed by the rock garden, including the frame, is going to be X plus 1 multiplied by X plus 1, length times width. And we're told that the area we're covering is a square area of the area 12 foot square. So X plus 1 times X plus 1 is equal to 12 foot square. How do I solve this? I do not set X plus 1 to be equal to 12. I need to multiply this out. And or this is same as X plus 1 all squared is equal to 12 foot square. What would be the easier way to solve? Because I know something is squared on the left hand side and the other right hand side is just a number, I can take a square root of both sides. Square root and square cancels out, but when you do that, you need to put plus and minus. So that becomes X plus 1 is equal to plus and minus square root of 12 is square root of 4 times square root of 3, and square root of 4 is same as 2, so that becomes 2 root 3. So then the length of X is X plus 1 is the positive version, or X plus 1 is the negative version of the square root. And then from here, I subtract 1 from both sides, and I have one length being negative 1 plus 2 root 3, and the other length being negative 1 minus 2 root 3. Now think about this. You have negative 1 plus another negative number. You're going to get the length to be a negative number here. That is, we can't have the length in real life to be a negative number, so we discussed that, we discard that solution, and we're just left with one solution. And because 2 root 3 is bigger than 1, it is going to be, we're going to be left with a positive number. So the length, the valid length, is going to be negative 1 plus 2 root 3. Now from here, since we found out the length of the rock garden or inside perimeter, we need to figure out the area. To do that, it's going to be x times x, or negative 1 plus 2 root 3 times negative 1 plus 2 root 3. This is like using to multiply this out, okay? Because they are not like radicals, you can't just add this, what's inside the parentheses. What you could do is use distributive property, basically doing FOIL. First with first, so it's going to be negative 1 times negative 1, which is negative 1 squared. Outside, that means negative 1 times 2 root 3 is negative 2 root 3. The two inside terms, 2 root 3 multiplied by negative 1 is negative 2 root 3. And then last with the last, so 2 root 3 multiplied by 2 root 3 is 2 root 3 all squared. Okay, negative 1 squared is 1. Negative 4 root 3 minus negative 4. Negative 2 root 3 minus 2 root 3 is negative 4 root 3. Now this is 2 times 2 is 4, and square root of 3 times square root of 3 is just 3. So it's 4 times 3, which is 12. And that leaves me with 13. 1 plus 12 is 13 minus 4 root 3. So the area that is covered is 13 minus 4 root 3 foot squared. And if I use the calculator, 4 times root 3 and subtract that from 13 is going to give me 6.07 feet square. Okay, alright, so then let's go back to our imaginary number. Remember from our last lesson, we said that we are going to define I, the imaginary number, to be square root of negative 1. This is a very, very special number because up to now we said that you cannot have a square root of a negative number. But now we are defining something new, okay? Remember, think of it as we've just expanded into a new dimension, okay? So far you only see 3D, but now we've gone into 4D. That's kind of cool. All right, and I can be used to represent any negative square root number. For example, if you have square root of negative 25, that can be written as negative 1 times 25. Negative 25 is negative 1 times 25, so that can be broken up as square root of negative 1 times square root of 25, which is square root of negative 1 is defined as I, and times square root of 25 is 5, so that becomes 5I. Or square root of negative 7 is negative 1 times 7 square rooted, so that's same as square root of negative 1 times square root of 7, which is same as I root 7. This is just the notes from last lesson. So you are going to do Desmos card number 1 to 5 now. Please pause the video and try to do them yourself. First card is a card sort. You are sorting the numbers into imaginary or real. Let's put the imaginary on the left and real on the right. Okay, so remember, when we're talking about imaginary, we're really talking about square root of some negative number, just like this, or anything that simplifies to involve I eventually. So in this case, square root of negative 4, because we're talking about square root of a negative number, that is going to be imaginary. Square root of 6. This is positive square root of 6, positive 6. So this is real. This is just a real radical that you can use on the calculator to calculate. Square root of negative 5, because of the negative in the radical, it's going to be imaginary. Okay, square root of 3 divided by 2 is real. Remember, the only thing that's going to be imaginary is if it ever involves square root of a -1, or if it simplifies to have something that has square root of a negative number. So for example, in this case, that has a square root of negative number, and then square root of negative number here. Okay, do I have, and square root of negative number here. Okay, what about negative square root of 10? Square root of 10 is a real number, and negative of that number is just real, as opposed to square root of negative 10. There is a big difference between square root of negative 10 versus negative square root of 10. Pi over 3. Pi is just, it's a real number, it's an irrational number. Remember, it's a number, it's a decimal that goes on forever. And similarly, pi over 3 will be a real number, and 5 over 2 will be a real number, and 4 over 5 will be a real number, and 5 will be a real number, and -1/3 will be a real number. So you have 10 real numbers and 6 imaginary numbers. Okay, card number 2, represent square root of -25 by using I. I can use the equation symbol. And so square root of SQRT of -25 is same as square root of SQRT of -1 times SQRT of 25. Okay, so then this I know is the same as square root of that's going to be I times square root of 25 is just 5. So that is same as writing equals 5i. So you can use the text box. You can move this to just make it a little bit more visible, and that's showing your work. Or you can certainly draw it as well. What about square root of -32? It's same as square root of that should not be, not negative here. Okay, square root of -7. I'm thinking about the previous example. Okay, square root of -1 multiplied by square root of 32, which can be broken up as square root of 16 and square root of 2. 16 times 2 is 32, and 32 multiplied by -1 is -32. So that is same as I times square root of 16 is 4 times square root of 2, which is same as 4 is the whole number, so it's going to come here, and then followed by an I, and then root 2. Lastly, 5 square root of -12 can be represented as 5 multiplied by, remember the default between the number and square root is multiplication, multiplied by square root of -1 times square root of 12, which is same as square root of 4 times square root of 3. And I know that's same as 5 times square root of -1 is same as I times square root of 4 is just 2 times square root of 3. And this is same as I can multiply the whole numbers. 5 times 2 is 10, and I have I here multiplied by root 3. So it's 10I root 3, and this is an imaginary number.